To explain about the introduction for the Grimm theorems. Okay, firstly, the Grimm theorem has many applications in physics, one of which is solving two-dimensional flow integral, stating that the sum of fluid outflowing from a volume is equal to the total outflow sum about an enclosing area. In plane geometry, and in particular area surveying, Green's theorem can be used to determine the area and centra of the plane figure solely by integrating over the perimeter. In vector calculus, Green theorems relate a line integral around a simple closed curve C to a double integral over the plane region D bounded by C. It is the two-dimensional special case of Stokes theorem.
Okay, let C be a positively oriented, piecewise, smooth, simple closed curve in A plane, and let D be the region bounded by C. If length M are function of xm defined on an open region containing D and having continuous partial derivative there, then where the path of integration along C is anti-clockwise.
To explain the application of Green's theorem on magnetic flux. From question 1, the information that we get is Pxy equal to x, Qxy is equal to negative y, F is equal to x negative y. Since x equal to P and negative y is equal to Q, so we substitute P and Q into the vector of F that produce F equal to PQ. And the equation also stated the formula of R is x squared plus y squared less than and equal to 9. Next, from the Green theorem, we know that the double integral of R is equal to integral of C. So now we will find the partial differentiation of P in terms of x and Q in terms of y. The answer we get for P in terms of x is 1, Q in terms of y is negative 1. Now we substitute this answer into the equation of double integral of R, and we will get double integral of R to dA. Next, by using polar coordinate, we will find the limit of R and theta. First, we will compare x squared plus y squared less than and equal to 9 to x squared plus y squared less than and equal to r squared. From these two equations, we will get r is equal to plus minus 3. Then, we will substitute this limit in an equation of double integral 2r dr d theta. And we will solve this equation and get the answer of 18 pi.
So my question is, use the Green's theorem to evaluate the integral of area bounded C, y x squared dx minus x squared dy, where C is shown as below. So we know that here is a question of x squared plus y squared equal to 25, which is, we know that is a equation of half circle. So here is the question, and the solution, which is start from step 1. First, let's notice that if we walk along the path in the direction indicated, then our left hand will be over the enclosed area, and so this path does have the positive orientation, and we can use Green's theorem to evaluate this question. So from the integral that we have a value of P equal to yx squared and a value of Q equal to negative x squared. So we need to remember that P, the value of P is multiplied by x and value of Q is multiplied by y, and don't forget to pay attention at the in front of the sign. So for the next step, which is step 2, we using a Green's theorem, the line integral. So the Green theorem line integral becomes the area bounded of cy x squared dx minus x squared dy equal to area bounded of D negative 2x minus x squared dA, which is D is the region enclosed by the curve. For the next step, which is step 3, since D is just half circle, it makes sense to use polar coordinate for this problem. So the limit of D in polar coordinate start from theta. It start from 1 over 2 pi until 3 over 2 pi. And for the next value of R, the value start from 0 until 5. So for the next step, which is step 4, now all we need to do is evaluate the double integral after first converting to polar coordinate. So here is the evaluation work. Based on the question, the integral of c yx squared dx minus x squared dy equal to area bounded of d negative 2x minus x squared dA. So the double integral start from the value of theta, which is from 1 over 2 pi until 3 over 2 pi, and the value of r start from 0 until 5. So don't forget to put the value of r according to the polar coordinate formula. So r is times with negative 2r cos theta minus r square cos squared theta dr d theta. So the double integral, you can see here the value of negative 2r squared cos theta minus 1 over 2r cubed 1 plus cos 2 theta dr d theta. So for the first integral for integral of r, so we can get the value of negative 3 negative 2 over 3 r cubed cos theta minus 1 over 8 r power of 4 times to 1 plus cos 2 theta. So the integral for the next integrate, which is value of theta from 1 over 2 pi until 3 over 2 pi, we can get the final answer, which is 500 over 3 minus 625 over 8 pi, which is for the last answer is negative 78.7703.
This is the graph for equation of x squared plus y squared less than and equal to 9. The x-axis shows that the x has the value of positive 3 and negative 3, and the y-axis has the value of positive 3 and negative 3. This is the graph that will be obtained from the equation of x squared plus y squared equal to 25. The x-axis shows that the value of the x is positive 5 and negative 5. The y-axis has the value of positive 5 and negative 5.